So we have a bug in our program. That means whatever the program is doing is not what we were hoping it would do. When the user types in 3 for the goblin position, we're not getting well done. We're always getting no, the goblin is not there. Hopefully you're pausing these videos and trying it out and playing with the code as we go along. So this is something I should have said before. Pause whenever you want, try the code, play with it, and then come back here to carry on the videos. Now, in order to fix this bug, I'm going to first talk about another important topic. I did mention this first project is about having an overview of lots of important topics in programming. Now, I've started talking about these 4 pillars of coding. We've seen the first 2, store. We need to store information in our program. Now, store is more complex than it sounds, and we're going to start hinting at why store is there's more to it than meets the eye. We've also seen decide, but let me go back to store. I'm going to open the console again. The console or the REPL, it's this area, it's sort of a side project, if you like, where we can try things out and then go back to our main program. Let me create a couple of variables. My number equals 12. Let's go for 42. There you go. Random number. Some of you will get the idea of, I'm sure most of you will understand where 42 comes from. Anyway, and let's go for my name, some name. I'm coming up with different variable names. I want to stress that these are names I'm coming up with, right? So when you choose a variable name, it's up to you. We'll talk more about choosing names that describe. The more descriptive they are, the easier it is to read the code, but we'll come back to that. Let's say some name equals, let's go for Trevor, there you go. Otherwise, I'm always writing Stephen. It's a bit too self-centered. Okay, so I've created 2 variables, 2 boxes. One is labeled my number, one is labeled some name. One has 42 in it, one has Trevor. Clearly, the content of these variables is different. I can say my number and I get 42. I can say some name and I get Trevor. But it's not just that the content is different. The type of data is different between my number, what's stored in my number, and what's stored in some name. This is what we're going to be talking of, data types, the type of data. And I can ask Python to tell me what type of data is stored in my number. And it tells me, ignore class for now, I'm looking at what's after this. This is an int, it's an integer, it's a whole number. So Python understands that 42 is a whole number, and the data type is the integer, int. And if I say what type of data is some name, and that's where the string comes in. I've already used the term string, it's a string of characters. So integer and string, int or str for short in Python, they are 2 different types of data, 2 data types. And this is a really important concept in programming, because what Python can do with data depends on its data type. I'll show you an example. Let's say I want to say my number times 10. So my number is 42, 42 times 10, let's work it out, 420. And you might think, okay, I've got a glorified calculator. Python can work arithmetic sums for me. Okay, so that's the multiplication symbol, like in most places in computing. Let's try the same thing with some name. Now, some name is a string. It's a string Trevor. So what's going to happen when I multiply it by 10? Well, Python says Trevor, 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 puts Trevor 10 times. It concatenates. We've talked about concatenation before. There's another way of concatenating strings, repeating the same string 10 times. Now, I've used the same symbol, the multiplication symbol, and multiplied by 10 in both instances. But Python treated this differently. Why? Because it recognized in the first instance that it's dealing with something of type integer. And it says, how do I multiply when I have a number, whole number? I do one thing. But in the second instance, some name is a different data type. It's a string. And therefore, Python has a different set of rules. When I need to multiply a string by 10, I'm going to do something else. I'm going to put the string 10 times. We'll see a lot more as we understand more about coding. We'll see how different data types have different properties and they behave in different ways. But for now, that's all I want to say. So, why is this relevant? Let me do the following. Let me say another number equals, we've used input before, input, type in a number. Notice I always put colon in the space. Why? Because the space is a character. So I wanted to actually show the space when it prints out. Otherwise, it's sort of the cursor is right against the colon. And let's go for 15, any number. Okay, so another number is now a variable with the number 15 in it. So now you can, what's another number times 10? Well, 15 times 10 is 150, right? Well, no. What do we have here? Now, I've already hinted at where the problem is when I said Trevor times 10. You can see that the same thing happened here. Python looked at this and said, you want to do 15 times 10, so it's 151515. Clearly, it didn't look at it as a maths problem, as an arithmetic problem. Why? Because if I look at the type of data of another number, it's not an integer. Even though I typed in 15, which I would have thought is a number, Python doesn't see it that way. We'll see why in a bit. So another number is the character 1 and the character 5 put together, which we know is 15, but from Python's point of view, they are just the characters 1 and 5. Since another number is a string, when I multiply by 10, it says, I'm going to put the string 10 times in a row, just like Trevor, 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 Trevor. Here I have 15151515. Now, couple of problems here. First of all, why does Python do that? Doesn't it know that, that's a number? The problem is that we can use input for any type of input from the user. In fact, in our program, if I go back to the top, we used input here to give us a name. A reminder that Python does not understand what you put inside the quotation marks. That's for the human being using this program. Type in your name doesn't make sense to Python. Type in a number doesn't make sense. So input has no way of knowing your intention. I'm expecting a string or I'm expecting an integer. So it will always give you back a string. And then it's up to you to figure it out, which we'll have a look in a bit. Okay, so why is this a problem? Because if I say, you might remember the equals from last time. So let me write a rather silly line. Is 5 equal to 5? And Python will say, of course they are. They're both the same thing. How about this? Is 5 equal to 5? Now, you might think, hey, you just put some extra punctuation marks there. Who cares? Python does. Because this is false. Why? Python looks at the first one and says, that's the string. It's the character for the number 5. It's not the number 5. It's the symbol, if you like, that represents 5. Whereas this is different. This is the actual number 5, the one that comes after 4 and before 6. So from Python's point of view, these are different, they're actually different types of data, so they can never be equal. A string cannot be equal to an integer because they're different types of data. It's like comparing, oranges with cars. You can't, they're different. Luckily, we have a way of converting a string into an integer if it's possible. So if I say int speech marks 5, Python says, okay, you want me to convert this into the integer 5. So this is going to be a number. Of course, if I try to do it with Stephen, Python's going to struggle there. It's going to say, I can't do that, it's an invalid. So you can only use this if the string is an actual integer. We'll see how we're going to use this in our code, but we'll be talking a lot more about data types. I'm just going to show you one more here. So let's go for one more number equals 5.5. Now this is not a whole number, it's not an integer, and Python, like most programming languages, has a different data type for whole numbers and for numbers with a decimal point. And this is what's called a float, because it has a floating point, it's a floating point number. So far we've seen 3 data types: the integer, the whole number like 5 or 42, the float, which is numbers that are not integers, basically a number with a decimal point, and we've seen strings of characters. So we can see what's happening here. In a future course, we'll talk more about debugging, the art, if you like, or the dark art of finding bugs and fixing them. But for the time being, I've sort of helped you find where the bug is. The bug is that player guess even though the user is typing in a number, input gives us back a string. So player guess is a string, whereas goblin position is a number. This is the same as when I compared speech marks 5 with 5. Python will never say they're the same. So I have two options here. I can either change this to a string, which I could do, but I'm going to use the other option. I'm going to say, I want player guess to be equal to whatever player guess is, convert it into an integer. And this is something we'll see a lot in coding, which is you might think of an equals and think it's the same as in maths. In programming, it's a bit different. Line 12 is saying, I want the box labeled player guess. I want it to have something else in it. We can't have two boxes named player guess. So whenever I do this, I'm replacing what was in player guess before. But I'm saying, take whatever is in player guess now, change it into an integer, and the result is what I want you to put in the same box. So whenever you have something like this, Python first looks on the right hand side and says, do I know what player guess is? Yes, I've got a variable. It has the character, the string 3, or whatever number you put in. Let me convert it to an integer, and now I'm going to place that integer in the box called player guess. So I am changing what's inside the box. In this case, I'm changing it from the string 3 to the integer 3. Let's see whether this fixes the problem. Type in your name. Now I'm going to cheat again. I know that the goblin is in position 3 because that's what I've written in the code. So as a user, I'm going to pretend I'm guessing 3. And now I have well done. This doesn't mean the code is working. Let's try the other options. We always need to test our code. Here we have two parts. Let's test both parts. Stephen, let's try some other number, 2. And now it says no, the goblin is not there. So we've now gone back to this if statement, and this was the decide. We asked the computer here, can you decide whether to print well done or to print no, the goblin is not there? One quick, well, not reminder, because I haven't told you yet. We can have more than one line in each of these blocks. For example, here I can say well done, and I can say something else. Now, all we know is print so far, right? So I'm going to put another print line, but we'll see that there's more than just print in programming. Print, you've done really well, whatever. As if this game is, never mind, you've done really well, there you go. Let's be nice and positive. So you can see that lines 16 and 17 both have an indent. So they form one block. If this condition is true, if player guess is the same as goblin position, here's the colon, Python will look at all the lines after the colon have an indent. In this case, both of them. So both will happen when I guess correctly. Stephen, the goblin is still in position 3, and you can see that both lines were printed. Well done. You've done really well, I went to write. There you go. And if I run it again and get it wrong, for example, put kitchen cupboard number 1, I only have no, the goblin is not there, unless I write more lines of code there. Good. So we have now fixed the bug. By doing so, we've learned about data types, different types of data that variables can have, that any data can have. We have a working game, but there's a bit more we want to do, which we'll have a look at in the next videos.